I am the virtual teacher at Egnatia Career College. Today we'll teach branch circuits for the bedrooms, study, and halls. Branch circuits for the living room and front entry. This is video number 10. Branch circuits for the bedrooms, study, and halls. After studying this unit, you should be able to explain the factors that influence the grouping of outlets into circuits. Estimate loads for the outlets of a circuit. Draw a cable layout and a wiring diagram based on information given in the residence plans, specifications, and Canadian Electrical Code (CEC) requirement. Select the proper wall box for a particular installation. Explain how wall boxes are bonded to ground. List the requirements for the installation of fixtures in closed closets. Make connections for three-way switches. Grouping outlets. A branch circuit is all of the wiring from the final overcurrent device in the system to the point of utilization. The grouping of outlets into branch circuits must conform to CEC standards and good wiring practices. There are many possible combinations of groupings of outlets. In most residential installations, the electrician usually does the circuit planning. In larger, more costly residences, the architect may complete the circuit layout and include it on the plans. In either case, the electrician must ensure that the branch circuits conform with the CEC. The receptacles in this room are connected with the lighting circuit. As per Rule 26-656, 1, all receptacles 20 amperes or less are to be AFCI protected in dwelling units. It is not stated that luminaires cannot be connected to arc fault circuit interrupter (AFCI) branch circuits, though in the past it was often not done. Due to the additional cost of running separate branch circuits for lighting, they are connected in this dwelling. It should be noted that some luminaires or fans connected to these AFCI branch circuits may cause nuisance trips, though newer AFCI protection devices make this much less likely. Some electricians will insist upon separating lighting and receptacles. Additional cost is the only drawback of this practice. Cable runs. Studying the great number of wiring diagrams throughout this text, you will find many ways to run the cables and make up the circuit connections. Sizing of boxes that will conform to the CEC for the number of wires and devices is covered in great detail. When a circuit is run through a recessed fixture like the type shown in this figure in Unit 10, that recessed fixture must be approved for through wiring, a subject discussed in Unit 10. When you are unsure whether a fixture can accommodate the extra wiring for a run to another fixture or some other part of the circuit, it is best to design the circuit so that the wiring ends at the recessed fixture with just the conductors needed to connect it. The grouping of outlets into circuits must satisfy the requirements of the CEC, local building codes, good wiring practices, and common sense. A good wiring practice is to divide all loads as evenly as possible among the circuits. Ensure that no more than 12 outlets are placed on a 2-wire circuit. Keep cable runs as short as possible. Use boxes that have adequate space for conductors and devices. See Rules 8-104 and 8-304. Estimating loads for outlets. Here are the formulas where you see how to calculate the loads. Here is one example. Here is another example. You can pause the video and take your time to understand the calculations. In most code calculations, watts are used in calculating the demand on service or feeder conductors because the Canadian Standards Association (CSA) requires that all electrical equipment be marked with a wattage or kilowatt rating, Rule 2-100, 1E. Most residential loads are resistive, therefore, the power factor of 1 gives the same value to the demand watts as volt amperes, and kW ratings are equivalent to kVA values. Therefore, this text uses the terms wattage and volt amperes when calculating and/or estimating loads. Building plans typically do not specify the ratings in watts for the outlets shown. When planning circuits, the electrician must consider the types of fixtures that may be used at the various outlets, based on the general uses of the receptacle outlets in the typical dwelling. The CEC specifies that the maximum number of receptacle and lighting outlets that may be connected to any two-wire branch circuit, 15A or 20A rated, in a residence is 12 outlets, Rule 8-304(1). However, Rule 8-304(3) could permit more outlets if there is a maximum loading of 80% on the overcurrent device and the load on the outlets is known. The layout of the receptacles on the walls must satisfy Rule 26-720 and Rule 26-724. This should virtually eliminate the use of extension cords, one of the highest reported causes of electrical fires. Rarely, if ever, would all of the outlets be fully loaded at the same time. Circuit Loading Guidelines, Rules 8-104(6) and 8-304(3). A good rule to follow in residential wiring is never load the circuit to more than 80% of its capacity. A 15 ampere, 120 volt branch circuit would be calculated as 15 times 0.80 equal to 12 amperes. Or 12 amperes times 120 volts equal 1440 volt amperes. Certain fixtures, such as recessed lights and fluorescent lights, are marked with their maximum lamp wattage. Fluorescent fixtures also list their ballast current. Other fixtures, however, are not marked, and the electrician does not know the size of the lamps that will be installed in them. Furthermore, the electrician does not know the exact load that will be connected to the receptacle outlets, as it is difficult to anticipate what the homeowner may do after the installation is complete. The room in which the outlets are located gives some indication of their possible uses. Therefore, the electrician should plan the circuits accordingly. Load estimation. The electrician can estimate the lamp loads in the lighting fixtures by determining the lamp wattages that will probably be needed to provide adequate lighting for an area. Many lighting manufacturers publish useful information and recommendations in catalogs and on the internet. Estimating the number of outlets by assigning an amperage value to each. One method of determining the number of lighting and receptacle outlets to be included on one circuit is to assign a value of 1 ampere to each outlet, to a total of 12 amperes. Thus, a total of 12 outlets can be included in a 15 ampere circuit. Although the CEC limits the number of outlets on one circuit to 12 outlets, local building codes may specify fewer. Therefore, before planning any circuits, the electrician must check the local building code requirements. All outlets will not be required to deliver 1 ampere. For example, closet lights, night lights, and clocks use only a small portion of the allowable current. A 60-watt closet light draws less than 1 ampere. Formula shows I equal to 0.5 amperes. If low wattage fixtures are connected to a circuit, it is quite possible that 15 or more lighting outlets could be connected to the circuit without a problem. On the other hand, if the load consists of high wattage lamps, the number of outlets would be less. In this residence, estimated loads were calculated at 120 volt amperes, 1 ampere, for those receptacle outlets intended for general use. To estimate the number of 15 ampere lighting branch circuits desired for a new residence, where the total count of lighting and receptacle outlets is, for example, 80 divided by 12 equal to 6.7 15 ampere branch circuits. We divide by 12 because each outlet counts as 1 ampere. 12 amperes is 80%, or the maximum for a 15 ampere circuit, as 15 times 80% equal 12. Rule 8-304(1). In residential occupancies, there is great diversity in the loading of lighting branch circuits. Caution. This procedure for estimating the number of lighting and receptacle outlets is for branch circuits only. Where the branch circuits in the kitchen, laundry area, and other areas supply heavy concentrations of plug-in appliances, the 1 ampere per receptacle outlet assumption is not applicable. These circuits are discussed in more detail in Units 14 through 16. Review of how to determine the minimum number of lighting circuits. 1. Connect 12 outlets per circuit. The required number of outlets should be divided by 12. This will show the minimum number of branch circuits, Rule 8-304, 1. 2. Estimate the probable loading for each lighting and receptacle outlet. Do not include the small appliance receptacle outlets covered by Rules 26-720 through 26-724. Try to have a total load not over 1,440 volt amperes for each 15 ampere lighting circuit. 3. Alternatively, add up the actual loading of outlets in a circuit. Verify that the overcurrent device is not loaded to more than 80% of its capacity, and the number may, in this instance, exceed 12, Rule 8-304, 3. Including outlets for smoke alarms is a good example of a situation in which the number could exceed 12. The wattage of a 120-volt smoke alarm is approximately 0.5 watt. Methods 1 and 3 are laid out in the CEC. Method 2 is only a guideline because the general lighting loads in homes are so varied. As the electrician lays out the circuits of a residence, these guidelines will generally provide adequate circuitry for both lighting outlets and receptacle outlets that are intended for general lighting, not appliance circuit receptacle outlets. Be practical. Consider the diversity of uses. Divide loads evenly. It is mandatory to divide loads evenly among the circuits to avoid overloading some while leaving others lightly loaded. At a main service panel, do not connect the branch circuits and feeders to result in, for instance, 120 amperes on phase A and 40 amperes on phase B. Look at the probable and/or calculated loads to attain a balance of loads on the A phase and the B phase. Symbols. The symbols used on the cable layouts in this textbook are the same as those found in the legend of symbols on the electrical plans for the residence. Pictorial illustrations are used on all wiring diagrams in this text to make it easy for the reader to understand the diagrams. Drawing the wiring diagram of a lighting circuit. The electrician must convert information from the building plans to the form most useful for planning an installation that is economical, conforms to all code regulations, and follows good wiring practice. To do this, the electrician makes a cable layout and a wiring diagram to clearly show each wire and all connections in the circuit. After many years of experience, skilled electricians will not always prepare wiring diagrams for most residential circuitry, because they have the ability to think the connections through. An unskilled individual should make detailed wiring diagrams. The following steps will guide you in preparing wiring diagrams. You will be required to draw wiring diagrams in later units of this textbook. As you work on the wiring diagrams of the many circuits provided in this text, note that the receptacles are positioned exactly as though you were standing in the center of the room. The CEC does not address receptacle orientation on the wall. Many electricians install receptacles with the ground pin on top. This provides for an added measure of safety. If a plug cap was not fully plugged in and a metal faceplate or other electrically conductive object should fall, it would hit the ground pin and not the live plug blades. 1. Refer to the plans and make a cable layout of all lighting and receptacle outlets. 2. Draw a wiring diagram showing the traveler conductors for all three-way switches, if any. 3. Draw a line between each switch and the outlet it controls. For three-way switches, do this for one switch only. This is the switch leg. 4. Draw a line from the neutral bus bar on the lighting panel to each current-consuming outlet. This line may pass through switch boxes, but must not be connected to any switches. This is the white grounded circuit conductor, often called the neutral or identified conductor. It is not truly a neutral conductor unless it is part of a multi-wire, 3-wire circuit. Note: An exception to step may fourth be made for double pole switches. For these switches, all conductors of the circuit are open simultaneously. They are rarely used in residential wiring. 5. Draw a line from the ungrounded, hot terminal on the panel to connect to each single pole switch and unswitched outlet. Connect to common terminal of one 3-way switch only. 6. Show splices as small dots where the various wires are to be connected. In the wiring diagram, the terminal of a switch or outlet may be used for the junction point of wires. However, the CEC does not permit more than one wire to be connected to a terminal unless the terminal is a type approved for more than one conductor. The standard screw-type terminal is not approved for more than one wire. 7. Mark the color of the conductors, see Figure 11.3. Note that the colors selected: black, B, white, W, and red, R, are the colors of 2 and 3 conductor cables. You could use colored pens or markers for different conductors when drawing the wiring diagram. Use a pencil to indicate white conductors. You can also draw all the conductors in the same color, pen or pencil, and write the letter of the color beside each conductor. Note this on the diagram, Rule 4.022. Estimating cable lengths. The length of cable needed to complete an installation can be estimated roughly. It may be possible to run the cable in a straight line directly from one wall outlet to another. However, obstacles such as steel columns, sheet metal ductwork, and plumbing may require the cable routing to follow a longer path. To ensure that the estimate is not short, make all measurements square. For example, measure from the ceiling outlet straight to the wall, and finally measure straight over to the wall outlet. Add 300 mm of cable at each cable termination. This allowance is for the 150 mm of conductor needed to make connections in the junction and outlet boxes. Check the plans carefully to determine where the cables can be routed. Receptacle branch circuit A18 for front bedroom and study. The receptacles in the bedrooms and living room are split-switched receptacles. Half the receptacle, normally the bottom half, is controlled by a wall switch in the room, and the other half is energized continuously. Receptacles in a dwelling must be tamper-resistant, as per Rule 26-706. These receptacles must be clearly marked tamper-resistant, or TR. Radios, televisions, and other electrical items not intended to be controlled by the wall switch will be plugged into the unswitched, hot continuously, half of the duplex receptacle. The recessed closet light is controlled by a single pole switch outside and to the right of the closet door. The outside weatherproof receptacle outside the study/bedroom is connected to circuit A24. The front bedroom circuit is fed from A18. Checking the actual electrical plans, we find one television outlet and one telephone outlet are to be installed in each bedroom. Television and telephones are discussed in Unit 23. Table 11.1 summarizes the outlets in the front bedroom and the estimated load. Branch circuit A24 outside receptacles. Branch circuit A24 is a 15 ampere circuit providing power to the outside receptacle outlets for this house. The receptacles are Class A Type G round fault circuit interrupter (GFCI), protected with a weatherproof cover on the receptacle outlet box. Rule 26-722 states that all outdoor receptacles 2.5 meter or less above ground or grade level shall be Class A Type GFCI protected. Ordinary receptacles may be installed above 2.5 meter, but must incorporate a weatherproof cover. Cover plates marked wet location only when cover closed shall be installed facing downward at an angle of 458 or less from horizontal, and located at least 1 meter above finished grade and not in a wet location. Rule 26-708-3. Determining the wall box size. The electrician must consider several factors when determining the size of the wall box. The number of conductors entering the box. The types of boxes available. The space allowed for the installation of the box. Sizing boxes according to the number of conductors in a box, Rule 12 to 3034. To find the proper box size for any location, you must determine the total number of insulated conductors entering the box. The pigtails connected to the receptacle need not be counted when determining the correct box size. Rule 12, 3034, 1c states. An insulated conductor of which no part leaves the box shall not be counted. For example, 1. Count the number 14 AWG circuit conductors. 2 plus 3 plus 3 equals 8. 2. Add 1 conductor for each pair of wire connectors. 2. 3. Add 2 conductors for the receptacle. 2. Total 12 conductors. Once you know the total number of conductors, refer to CEC Table 23 and this Figure 3 to determine the box suitable for the conductors. Use the volume of the box plus the space provided by plaster rings, extension rings, and raised covers to determine the total available volume. If the box contains one or more devices, such as fixture studs or hickeys, the number of conductors permitted in the box shall be one less than shown in Table 23 for each type of device contained in the box. Bonding of wall boxes. The specifications for the residence state that all metal boxes are to be bonded. The bare conductor included in non-metallic sheathed cables, NMSC, or armored cable, BX, is connected to the bonding screw in the box. And, for receptacles, carries on from the connection in the box to the bonding screw on the receptacle. This conductor is used only to bond the metal box. This bare grounding conductor must not be used as a current-carrying conductor, since severe shocks can result. According to CC Diagram 1 and Rule 26 to 700, grounding-type receptacles must be installed on 15 ampere and 20 ampere branch circuits. This figure shows how to attach the bonding conductor to the proper terminal on the receptacle. Positioning of split-circuit receptacles. The receptacle outlets shown in the front bedroom and study/bedroom are split-switched receptacles. The top portion of such a receptacle is hot at all times, and the bottom portion is controlled by the wall switch. The electrician should wire the bottom of the receptacle as the switched section. Then, when the lamp is plugged into the switched bottom portion of the receptacle, the cord does not hang in front of the unswitched section. This unswitched section can be used for a clock, vacuum cleaner, radio, stereo, CD player, personal computer, television, or some other appliance where a switch control is not necessary or desirable. When mounting split-switched receptacles horizontally, locate the switched portion to the right. Positioning of receptacles near electric baseboard heating. When laying out receptacles in residential applications, ensure that any cords plugged into the receptacles do not pass over heat-generating sources such as baseboard heaters, or hot air, hot water, or steam registers. Rule 26, 724a. In Appendix B, Unit 17 discusses installing electric baseboard heating units and their relative positions below receptacle outlets. Fixtures in clothes closets. Clothing, boxes, and other material normally stored on closet shelves are potential fire hazards. These items may ignite on contact with the hot surface of exposed lamps. Rule 30 to 204 gives very specific rules about the location and types of lighting fixtures permitted in clothes closets. Light fixtures should not be installed above closet shelves. Fixtures may be installed on the ceiling in front of a shelf or above a closet door. See this figure for suggested clearances. The first floor electrical drawing shows recessed lighting fixtures being used in the closets as well as other areas of the house. These fixtures should be Type IC, approved for insulated ceiling use, Rule 30 to 906. When installed, these fixtures will be covered with a vapor barrier and blanketed with insulation. Because heat is not dissipated from insulation blanketed fixtures as rapidly as from other types of lighting fixtures, a higher operating temperature will exist. Type IC fixtures include a thermal cutout device to prevent the maximum temperature from being exceeded. Lighting branch circuit A14 for master bedroom. The residence panel schedules show that the master bedroom is supplied by circuit A14. Because panel A is located in the southeast corner of the basement workshop, the home run for circuit A14 is brought into the closest outlet to the panel. This would be the receptacle located in the hallway between the front and master bedrooms. Again, it is a matter of studying the circuit to determine the best choice for conservation of cable or conduit in these runs and to economically select the correct size of wall boxes. This figure and Table 11.2 show a sample device and wiring layout in which circuit A14 has 4 split-switched receptacle outlets in the bedroom. 1 receptacle in the hall, 1 outdoor weatherproof light. 2 recessed closet fixtures each on a separate switch, 1 paddle fan/light fixture. In addition, an outdoor GFCI weatherproof receptacle is located adjacent to the sliding door and is connected to circuit A24, which also includes the other outdoor receptacles. Because there are 2 entrances to this room, the split-switched receptacle outlets are controlled by 2 3-way switches. 1 switch is located next to the sliding door. The use of split-switched receptacles offers the advantage of having switch control of one of the receptacles at a given outlet, while the other receptacle remains live at all times. Next to the door to the hall is the other 3-way switch plus the 2 single-pole switches for the ceiling outlet and fan. Sliding glass doors. CEC Rule 26-724(c) covers spacing for receptacle outlets on walls where sliding glass doors are installed. Selection of boxes. In the master bedroom, the electrician may decide to install a 2-gang welded box or 2 sectional device boxes ganged together. The size of box depends on the number of conductors entering the box. Rule 12-3034(2)(c) stipulates that the number of conductors shall be reduced by 2 if the box contains 1 or more flush devices mounted on a single strap. Therefore, the number of conductors to be included in determining proper box size is 7 circuit conductors plus 2 conductors for each switch, for a total of 11 wires. 1. Add the circuit conductors 2 plus 2 plus 3 equals 7. 2. Add 2 for each switch 2 plus 2 equal 4. Total will be 11. Now look at the quick check box selection guide, Figure 3-16 in Unit 3. And select a box or a combination of gangible device boxes that are permitted to hold 11 conductors. For example, you can gang 276 by 51 by 64 mm. Device boxes together, 8 times 2 equals 16. Number 14 AWG conductors allowed. Lighting circuit for study and main bathroom. The study/bedroom circuit feeds the bedroom, which provides excellent space for a home office or den. Should it become necessary to have a 3rd bedroom, the changeover is easily done. Circuit A16 originates at main panel A. This circuit feeds the study/bedroom at the closet switch. From this point, the circuit feeds the closet recessed light and then onto the paddle fan/light. Here it splits to feed the hallway light and smoke/CO alarms. The other leg goes to the switches by the doors leading to the living room. This figure shows the cable layout for circuit A16. There are 4 split-switched receptacles in the study/bedroom controlled by 2 3-way switches. One of the receptacles is surge protected. The black and white conductors carry the live circuit, and the red conductor is the switch return for the control of the switched half of the split circuit receptacles. A paddle fan/light fixture is mounted on the ceiling. Table 11-3 summarizes the outlets and estimated load for the study/bedroom. Valance lighting. This figure shows one way to arrange the wiring for the paddle fan/light control. the valance lighting control, and the receptacle outlet control. Since this room is intended to be used as a study or home office, a personal computer will probably be located here. Since the study has switched receptacles in this room, a TVSS bar will be used to connect the power for a personal computer on the constant power section of the receptacle. The wiring requirements for telephone and data systems are discussed in Unit 23. Paddle fans. Paddle fans have become extremely popular in recent years. These fans rotate slowly, 60 to 250 RPM for home-type fans. The air currents they create can save energy during the heating season because they destratify the warm air at the ceiling, bringing it down to living levels. Branch circuits for the living room and front entry. After studying this unit, you should be able to understand various types of dimmer controls. Connect dimmers to incandescent lamp loads. Understand the phenomenon of incandescent lamp inrush current. Discuss Class P ballasts and ballast overcurrent protection. Discuss the basics of track lighting. Understand how to install a switch in a door jamb for automatic on/off when the door is opened or closed. Discuss the type of fixtures recommended for porches and entries. Discuss the advantages of switching outdoor receptacles from indoors. Define wet and damp locations. Lighting circuit overview. This figure shows a sample device and wiring layout for the living room area that is connected to circuit B16, a 15 ampere circuit. The home run is brought from panel B to the split-switched receptacle to the left of the sliding door. Split-switched receptacles are discussed in Unit 14. A 3-wire cable is then carried around the living room, feeding in and out of the other split-switched receptacles. This 3-wire cable carries the black and white circuit conductors plus the red wire, which is the switched conductor. Since these receptacles will provide most of the general lighting for the living room through floor and table lamps, it is a good idea to have some of these lamps controlled by the 3 switches. 2 3-way switches and 1 4-way switch. Only 1/2 of each receptacle is switched, Rule 26-720, K. The receptacle below the 4-way switch is required because the wall space is more than 900 mm wide, Rule 26-724, C. And there must be a receptacle within 1.8 m of any point along the wall line, Rule 26-724, A. Because it is unlikely that a split-switched receptacle will be needed in this location, a standard receptacle is used. Split-switched receptacles are discussed in Unit 14. Accent lighting above the fireplace is in the form of 2 recessed fixtures controlled by a single-pole dimmer switch. See Unit 10 for installation data and Canadian Electrical Code (CEC) requirements for recessed fixtures. Table 12-1 summarizes the number of outlets. An estimated load for the living room circuit. Unit 4 covers requirements for spacing receptacle outlets and locating lighting outlets, as well as spacing receptacles on exterior walls when sliding glass doors are involved, Rule 26-724, C. Track lighting. The plans show that track lighting is mounted on the ceiling of the living room on the wall opposite the fireplace, which is on circuit A15. Track lighting provides accent lighting for a fireplace, a painting on the wall, or an item, sculpture or collection that the homeowner wants to focus attention on. It is also used as task lighting for counters, game tables, or kitchen dining tables. Unlike recessed fixtures and individual ceiling fixtures that are fixed in place, track lighting offers flexibility because the actual lamp holders can be moved and relocated on the track as desired. Lamp holders, selected from hundreds of styles, are inserted into the extruded aluminum track at any point. The circuit conductors are in the track, and the plug-in connector on the lamp holder completes the connection. The track is generally fastened to the ceiling at the outlet box and with toggle bolts or screws. Various track lighting installations are shown in these figures. On the residence plans provided with this textbook, the living room ceiling has wooden beams, a challenge when installing track lighting that is longer than the space between them. There are a number of things the electrician can do. Install a pendant kit assembly that will allow the track to hang below the beam. This fixture may be supported directly by the outlet box if the weight does not exceed 23 kg, Rule 30-302-4. Install conduit connector fittings on the ends of sections of the track, then drill a hole in the beam, and use 16 mm EMT to join the track sections. Running lighting track through walls or partitions is not recommended. Run the branch circuit wiring concealed above the ceiling to outlet boxes located at the points where the track is to be fed by the branch circuit wiring. Where to mount track lighting? To install the lighting track at the proper distance from the wall, you must consider the ceiling height, the aiming angle, the type of lamp holder, the type of lamp, and the type of lighting to be achieved. For example, if you are designing an installation to illuminate an oil painting that is to be centered 1.65 meter, average eye level, from the floor, where the ceiling height is 2.75 meter. And the lamp holder and lamp information tell us that the aiming angle should be 60 degrees. You would find in the manufacturer's installation data that the track should be mounted 600 millimeters from the wall. If the ceiling height in this example was 2.4 meter, then the distance to the track from the wall would be 450 mm. Since many variables affect the positioning of the track, it is necessary to consult the track lighting manufacturer's catalog for recommendations that will achieve the desired results. The track itself must be properly grounded to the outlet box. The plug-in connector on the MOVable fixture also has a ground contact to ensure that the body of the fixture is safely grounded. The track lighting in the living room is turned on and off by a single-pole dimmer switch. Supporting track lighting. Each lighting track must be fastened at a minimum of 2 places. This provides the secure support required by Rule 30-302-1. If the track is extended, install at least one additional support for every 1.5 meter or less of extension. Load calculations for lighting track. For track lighting installed in homes, it is not necessary to add additional loads for feeder or service entrance calculations. Rule 8-200-1A includes lighting track load as part of the regular watts per square meter computations. For further information on track lighting, refer to lighting manufacturers' catalogs. Dimmer controls. According to their Canadian Standards Association (CSA) listing, solid-state electronic dimmers of the type sold for home use are intended only for the control of permanently installed incandescent fixtures. For residential installations, the dimmer commonly used is a 600-watt unit that fits into a standard single-gang wall box. Both single-pole and three-way dimmers are available. Existing single-pole or multi-way dimmers can be easily replaced with market products that offer features like 600-watt universal LED/incandescent smart Wi-Fi, and that allow control from anywhere using iOS or Android applications. Owners can add and name their devices and control them individually or as a room with a single button. Creating schedules, scenes, and customized experiences with adjustable fade rates, maximum/minimum illumination levels, and more. Electronic dimmers use triacs to chop the alternating current, AC, sine wave, controlling the amount of voltage supplied to the load. Compact 1000-watt dimmer units are available for use in 2-gang wall boxes. These boxes should be number 1004 boxes, which are 3 inches deep. This figure shows how single-pole and three-way solid-state dimmer controls are used in circuits. Auto-transformer dimmer control. This type of dimmer control has a continuously adjustable auto-transformer that changes the lighting intensity by varying the voltage to the lamps. When the knob of the transformer is rotated, a brush contact moves over a bared portion of the transformer winding to vary the lighting intensity from complete darkness to full brightness. This type of control uses only the current required to produce the lighting desired. Dimmer controls are used on 120 volt, 60 Hz single-phase AC systems. The operation of such controls depends on transformer action. so they will not operate on direct current (DC) lines. The electrician can prevent overloading of the dimmer control transformer by checking the total load in watts to be controlled by the dimmer against the rated capacity of the dimmer. The maximum wattage that can be connected safely is shown on the nameplate of the dimmer. In general, overcurrent protection is built into dimmer controls to prevent burnout due to an overload. Instructions are furnished with most dimmer controls to help prevent such burnout. These instructions state that the dimmers are for control of lighting only and are not to be used to control receptacle outlets. Serious overloading of the dimmer could result, since it may not be possible to determine or limit what other loads might be plugged into the receptacle outlets. Reduced voltage supplying a television, radio, stereo components, computers, or motors of any kind, such as those in vacuum cleaners and food processors, can result in costly damage to the appliance. Because they contain a bulky transformer, autotransformer dimmers are larger than solid-state dimmers. Autotransformers require a special box that is furnished with the dimmer. They are common in commercial establishments, whereas the smaller solid-state dimmer is most commonly used in residential installations. Dimming traditionally involved what is called forward phase dimming, and the newer technology in use is reverse phase dimming. The distinction is important because of the LED lamps and drivers that are now being used around the world. Driver is the term for the electronics that runs the LED lamp. Lack of resistance in LED drivers causes problems in the dimming of LED lamps. A reverse phase dimmer can help correct the issue using the cycle of power and how it is applied with a reverse phase or electronic low voltage (ELV) dimmer. This figure shows both a forward phase (TRAC-based) and a reverse phase (ELV-based) dimmer curve. As depicted in this figure, in forward phase dimming power comes in from the left but is suppressed or prevented from operating until it has gone through approximately 1/3 of the cycle, shown by the dots on the curve. Then power comes in quickly from the crossover, center horizontal line and goes to the correct level. In reverse phase dimming, power comes in normally through approximately 2/3 of the cycle's wave and then is cut out or suppressed for the last 1/3 of the cycle's wave. Both forward and reverse phase dimming provide the same amount of energy to the light fixture they are powering. The major difference is that with reverse phase dimming, the electronics in an LED driver or fluorescent ballast are powered first and dimming occurs second. We cannot physically see the difference in the two types of dimming, but the LED driver and/or the fluorescent ballast certainly notices the difference and will respond very differently to the different styles. Almost all dimmers made worldwide before 2010 were forward phase (TRAC) based. This explains why the LED drivers and/or fluorescent ballasts often do not work well when connected to existing dimmers. Since there are so many of these dimmers around the world, the leading manufacturers are working to try to make their LEDs and forward phase dimmers work together. However, because LED is a growth industry, there is a lot of room for error in the design. When you are choosing a dimmer device, make sure it is forward phase dimming capable. This point is especially important if you have existing dimmers. It is also important to note that the manufacturers of fluorescent lamps and ballasts have worked out many of these issues, and the majority of these projects that say dimming capable are forward phase dimming capable. Incandescent lamp load inrush currents. An unusual action occurs when a circuit is energized to supply a tungsten filament lamp load. A tungsten filament lamp has a very low resistance when it is cold. When the lamp is connected to the proper voltage, the resistance of the filament increases very quickly. Within 1/240 second, or 1/4 of a 60 Hz cycle, after the circuit is energized. During this period, there is an inrush current that is about 10 to 20 times greater than the normal operating current of the lamp. T-rated switches are required for many applications of tungsten filament lamps. Rule 14-508. Switches are generally not required in dwelling units. Canopy switches are required to be T-rated and have an ampacity at least 3 times the connected load if they are used to supply incandescent lighting. Dimmer controls for incandescent lighting. The wiring diagram in Figure 12H shows the circuit used to control incandescent lamps. The entire load is cut off when the internal switch is in the OFF position. These dimmers are available in single-pole and three-way switches. This figure shows a slider-type dimmer switch with a rocker-type on OFF switch, which allows the slider to remain at the same place, thus maintaining the same light level. Leviton manufactures a full line of dimmers ranging from rotary, toggle, and slider up to a designer series with special features such as remote control on one model. Depending on the model, dimmers are available for incandescent, fluorescent, and magnetic low-voltage fixtures for loads up to 600 or 1000 watts, with many models having matching paddle fan speed controls. Dimming fluorescent lamps. To dim incandescent lamps, the voltage to the lamp filament is varied, raised or lowered, by the dimmer control. The lower the voltage, the less intense the light. The dimmer is simply connected in series with the incandescent lamp load. In fluorescent lamps, the connection is not a simple series circuit. To dim fluorescent lamps, special dimming ballasts and dimmer switches are required. The dimmer control allows the dimming ballast to maintain a voltage to the cathodes that will maintain the cathode's proper operating temperature and allow the dimming ballast to vary the current flowing in the arc. This varies the intensity of light coming from the fluorescent lamp. However, some compact fluorescent lamps have an integrated circuit built right into the lamp, allowing it to be controlled by a standard incandescent wall dimmer. These dimmable compact fluorescent lamps can replace standard incandescent lamps of the medium screw shell base type. No additional wiring is necessary. They are designed for use with dimmers, photocells, occupancy sensors, and electronic timers that are marked incandescent only. This figure illustrates the connections for an auto-transformer type dimmer for the control of fluorescent lamps using a special dimming ballast. The fluorescent lamps are F40T12 rapid start lamps. With the newer electronic dimming ballasts, 32-watt rapid start T8 lamps are generally used. This figure shows an electronic dimmer for the control of fluorescent lamps using a special dimming ballast. Fluorescent dimming ballasts and controls are available in many types, such as simple on-off, 100% to 1% variable light output, 100% to 10% variable light output, and 2-level 100% per 50% light output. Wireless remote control is also an option. To ensure proper dimming performance of fluorescent lamps, make sure that the lamp reflector and the ballast case are solidly grounded. Do not mix ballasts or lamps from different manufacturers on the same dimmer. Do not mix single and two lamp ballasts. Age the lamps for about 100 hours before dimming to allow the gas cathodes in the lamps to stabilize. Without aging, sometimes referred to as seasoning, it is possible to have unstable dimming, lamp striation, stripes, and/or unbalanced dimming characteristics between lamps. Because incandescent lamps and fluorescent lamps have different characteristics, they cannot be controlled simultaneously with a single dimmer control. Do not control electronic ballasts and magnetic ballasts simultaneously with a single dimmer control. Always read and follow the manufacturer's instructions furnished with dimmers and ballasts. Without special dimming fluorescent ballasts and controls, a simple way to have two light levels is to use 4-lamp fluorescent luminaires. Then, control the ballast that supplies the center 2 lamps with one wall switch, and control the ballast that supplies the outer 2 lamps with a second wall switch. This is sometimes referred to as an inboard/outboard connection. Branch circuit for front entry, porch. This figure shows a possible device and wiring layout for the front entry and porch area. This area is connected to circuits A15 and A24. The home runs enter the 6-gang switch box next to the front door. From this box, the circuit spreads out, feeding the entry light, the stairwell light, the closet light, the porch bracket fixture, the 2 bracket fixtures on the front of the garage, 1 receptacle outlet in the entry, the track light in the living room, and the post light in the front lawn. The outdoor weatherproof GFCI protected by circuit breaker receptacle on the porch is connected to circuit A24 along with the other outdoor receptacles. Table 12-2 summarizes the outlets and estimated load for the entry and outdoor lights at the front of the house. The receptacle on the porch is controlled by a single-pole switch just inside the front door, which gives the homeowner control of decorative lighting plugged into the outdoor receptacle. Typical ceiling fixtures commonly installed in front entryways, where it is desirable to make a good first impression on guests, are shown in this figure. Typical wall-mounted porch and entrance lighting fixtures are shown in this figure. According to Rule 30-318, any wiring of light fixtures in damp or wet locations requires fixtures to be approved and marked for use in such locations. For example, the fixtures will be marked suitable for wet locations. The CEC defines partially protected areas under roofs, canopies, or open porches as damp locations. Fixtures to be used in these locations must be marked suitable for damp locations. Many types of fixtures are available. Always check the label on the fixture for CSA approval or consult with your electrical supplier to determine the suitability of the fixture for a wet or damp location. Probably the most difficult part of the A15 circuit is planning the connections at the switch location just inside the front door, because there are 6 toggle switches. Here, it is a description of how many wires for single pole or panel. This location is another challenge for determining the proper size wall box. Calculations shows 32 volume of wire required. An interesting possibility presents itself for the front entry closet. Although the plans show that the recessed closet fixture is turned on and off by a standard single-pole switch to the left as you face the closet, a door jamb switch could have been installed. A door jamb switch is usually mounted about 1.83 meters above the floor, on the inside of the 2x4 framing for the closet door. The electrician runs the cable to this point and lets it hang out until the carpenter can cut the proper size of opening into the door jamb for the box. After the finish woodwork is completed, the electrician installs the switch. The plunger on the switch is pushed inward when the edge of the door pushes on it as it closes, shutting off the light. The plunger can be adjusted in or out to make the switch work properly. These door jamb switches come complete with their own special wall box.